Good afternoon, students. My name is Samuel Chukwuemeka. Welcome to this video segment. In this video segment, we shall discuss the topic of permutations. And of course, the topic of permutations is under the study of combinatorics. Combinatorics is an area of mathematics. Please, before you continue with this video segment, I suggest that you view the videos on counting, where I introduced combinatorics. What is combinatorics all about? About arrangement of objects or elements. So please, it is important that you view that video on Introduction to Combinatorics, which is counting, before you view this video segment. Okay? Alright, what is permutations actually? Permutations is just the arrangement where we have an ordered arrangement, not just an arrangement but an ordered arrangement. Maybe you want to order it in a certain way, in ascending order or descending order, or you want this to come first and you want this to come last, but it is an ordered arrangement. Okay, so we can say that a permutation of a set of elements is defined as the ordered arrangement of the set of elements. That is the simple definition of a permutation. Permutation of a set of elements is just the ordered arrangement of the set of elements. Now, sometimes we want the set of elements to be arranged in a particular way. The elements might be 2, it might be 3, it might be 1. If it's a unit set, it's only one element. If it's 2, it can be 3 elements in the set or 4 elements in the set, depending on, okay, but we want it ordered. We want it arranged in an ordered way. And that is what permutation is all about. So let's take, for example, the elements ABC. Let's say we have a set. Let's say we have a set of elements ABC, right? And we want to arrange the elements of this set. Now, we want to consider the different ways by which we can arrange this element. What are the different ways? What are the different ways to arrange this element? Which means, what are the different permutations of this element? How many ways can we arrange it? So, we can have A, B, C, whereby the A comes first, B comes second, and C comes third. We can also have A, C, B, right? A is still first, and we interchange B and C. Then we can have B, A, C. Right? B is now the first, and we interchange A and C. Then we can also have B, C, A. Then, of course, this 2A is first, this 2B is first, and then C. We can have C, A, B, and then, of course, the next one, C, B, A. So, each one gets its turn. Here, A comes first in 2 arrangements, B comes first here in 2 arrangements, C comes first here in 2 arrangements. And if you look at the last, the same thing. Each one gets its turn twice. Okay, B and B here, C and C, A and A, each one gets its turn twice. Okay, so we have 6 ways. Okay, we have 6 ways to 6 permutations or 6 permutations. Now, what if I ask you A, B, C, D? So you will write A, B, C, D, A, B, D, C, A, C, B, D, A, B, D, C. I mean, it's gonna take a long time. And what if we have A, B, C, D, E, A, B, C, D, E, F? I mean, it's gonna take time to arrange those, right? It's gonna take a lot of time to arrange it. But what we're interested in this topic is actually how many ways can we arrange it? How many permutations can we do it? You know, it's gonna be time consuming for you to come and start arranging A, B, C, D. A, B, C, D, A, B, C, D, A, B, D, C, A, C, B, D. We won't waste time writing all of this, okay? So, but how many ways do you think that this can be arranged? That is the thing. And if we have A, B, C, D, E, A, B, C, D, E, how many ways can we arrange this? 5 elements. Okay, A, B, C, D, E is one way. A, B, C, E, D is another way. A, B, D, C, E is another way. And it's going to be long. Okay, now, mathematicians now came up and said, what are we going to do? To find a number of ways to arrange this. Now, that brings us back to, why are we even studying this? Why are we studying counting, combinatories? Why are we studying permutations? We are studying, and the next one we are going to do is combinations. What we are studying this because it is something, enumeration, counting. Counting is what we use in our everyday man. Okay, have you ever thought of the fact that, have you ever asked yourself, we have 5 zip codes in the United States, right? How many ways, and with different zip codes, each county has a zip code, if I'm sure, if each county or city has a different zip code. Now, do you think, how many ways has this been done to get all these 5 different zip codes for each county or city? Have you ever thought about that? Okay, think about the social security number. Think about your phone number, your telephone number. Your social security number, no 2 people have the same social security number. So, how many ways was the computer able to generate? Is it able to find, to generate 9-digit social security numbers without any 2 people having the same social security number? I mean, there are so many ways you can think about this. How many ways can you arrange if your company is producing products and you want to ship it? How many ways can you arrange 5 shipments in a truck without anyone in a certain order, without one hitting the other? You know, how many ways are you going to arrange people to stand in line so that this person comes first or this person comes last? How many ways are you going to form a committee? If you have a committee that you want, okay, you want this committee to have at least 5 men and 7 women. How many ways are you going to form this committee out of maybe 20 men and 30 women? How many ways can you form this committee to have at least 5 men and 7 women? How many ways can you do it if 2 women must be in the committee and must be seated close to each other? How many ways can you sit people around a circular table? So, all this is, you know, that is what we are going to solve in this topic, in this subject. That is why this is important. Okay, back to this. So we find that we have 6 ways of arranging the letters A, B, C, right? Okay, scientists now came up and said, what do we do? What easier way can we now solve this? What if we have maybe letters A, B? A, B. Assuming you are asked to arrange these letters. Set A, B. You can arrange A, B, or you can also arrange it as B, A. So it's 2 ways. It's 2 ways. This is 2 ways. And here is 6 ways. So we now came up with a formula that, okay, when we have 2 elements in the set, we now say it's 2 factorial, which will give you 2 times 1. And that gives you what? 2. When we have 3 elements in the set, we now say 3 factorial, which will give you 3 times 2 times 1. And that gives you what? 6. 6 ways. So if we have A, B, C, D, of course, if we have A, B, C, D, A, B, C, D as the set, and I'm not gonna, of course, I'm not gonna list this, although I can list it, but I want to make this video short. Okay, I can list it, but you already know what it will give us. What we're interested is in how many ways can we arrange these letters. This is 4 elements, 4 letters. So it will now be what? 4 factorial, which will give us what? 4 times 3 times 2 times 1. And that gives us what? 24 ways. 24 ways. 4 times 3 times 2 times 1. And that gives us 24 ways. Please make sure we put ways, since we, always put in our unit 2 ways, 6 ways, 24 ways. Okay, so we now come up with what we call, and this is read as 4 factorial. That is what is read. It's read as 4 factorial. You know what, I think I might have to raise this. So if we read this, this is read as 2 factorial. We call it the factorial notation. This is read as 3 factorial. So of course we have 4, we have 5, we have 6, and that means we have n. So n is now read as n factorial. N factorial. And this exclamation mark is what we call the factorial notation. The factorial notation, I know you might say, is an exclamation mark in English. I know. Yeah, we call it the factorial notation in mathematics. Imagine 2 symbols, a symbol having 2 different meanings. In English is the exclamation mark. In mathematics is the factorial notation. Isn't that isn't that interesting? Okay, so in your calculator, in your scientific calculator, in the calculator, on the computer, in your scientific calculator, you just have to, if you just press it, you have this notation, n factorial, in your calculator. So try to see how you can use it. Now, of course, if you go to my website, I will put some calculators on this, so you can use the calculators on my website as well. So this is now how we do it. Okay, so if we have, of course, since we have 4 factorial to be 4 times 3 times 2 times 1, which is 24, of course you know what 5 factorial will be. 5 factorial will be 5 times 4 times 3 times 2 times 1. 5 times 4 is 20 times 3, 60 times 2, 120. 120 ways. Okay? Now, so we have that n factorial will be what? N times, of course, the next one is n minus 1 times, of course, n minus 2, and it keeps going up to what? Up to 2 times 1, as you can see. So it keeps going, n times n minus 1 times n minus 2, up to 2 times 1. So this is now what we've introduced, factorial notation, which you can also say the number of permutations of n distinct objects or n distinct elements, of arranging n distinct elements or objects. Okay, is the same as the factorial notation. Alright, so we've listed for A, for number 1. And number 2, of course, is 6 ways. 6 permutations or 6 ways, it doesn't matter. Alright, number 3. How many permutations are there of A, B, C, D? I'm happy they didn't tell us to list it. They didn't tell us to list it. So, of course, you already know how many permutations are there is 24 permutations. 24 ways, or you can say 24 permutations. Yeah, if I list it now, it will extend this video, which I don't want. But you can try it, it will give you 24. 24 distinct ways. Yeah. Okay, let's continue. The next one is number 4. List the two permutations. List the two permutations of A, B, C, D. Now, well, sometimes when we have this set of elements, right? Let's say we have A, B, C, D. It's 4 elements. Now, sometimes you might need to just arrange 2. You know, arrange 2. Any 2 from this 4. You know, and that is the arrangement of n elements taking r elements at a time, okay, is defined as r permutations. R permutations. Let's say we have n and r, and I know why I'm saying n and r, because that's the standard. That's the standard, okay? That's the standard you see in a lot of textbooks. I don't want to bring up my own alphabets and you go to textbook and you see a different thing. Alright, now, sometimes we have this 4. Now, A, B, C, D. A, B, C, D. And we want to find 2 permutations of A, B, C, D. That means we have 4. N is 4. N is 4. But we want to take 2 at a time. We want to arrange 2 elements at a time. Okay, R is 2. So, what do? We can have AB, we can have AB, we can have BA, because AB, BA, right? Remember, order is necessary in permutation. When we go to combinations, it's going to be a different ball game. But I want you to understand this first, permutations. Then we can also have AC, and we have CA. Then we can have AD, and we have DA, right? Then we can have BC. Of course, we've not talked about BC. And we have CB. Then we can have a BD, and we have DB, right? Then we can have a CD, and we have DC. So this is 4 objects taking 2 at a time. So these are the 2 permutations of A, B, C, D. These are this question number 4 that I'm answering now. But how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 12 permutations. Okay? Or 12 ways. Let's say 12 ways. So you don't confuse 2 permutations with 12 ways. Alright? So the 2 permutations of A, B, C, D gives us 12 ways. Or 12 permutations. It still doesn't matter. Remember, this 2 has a hyphen, which means in 2s, taking 2 at a time. Okay? Now, you now ask yourself, right? We now have 4 perm 2, and you're not confused. What am I writing? Okay. Now, let me now say that n permutation of n elements taking r elements at a time can be represented as, you can represent it as superscript n permutation subscript r. You can represent it like this. I think this is the one you see on your calculator, on your scientific calculator. And like I mentioned earlier, I'll put these calculators also on my website, so you can easily use it. You can have it like this, or you can have it like this: subscript n permutation subscript r. Subscript and superscript. Superscript n permutation subscript r. or subscript N permutation, subscript R. Some textbooks write it this way. Or you can also have it like this, permutation of NR. Permutation of N objects taking R at a time. You can have it this way as well. Okay? So now, for 4 and 2, we now see, of course, that 4 palm 2, and you can say 4, I'm gonna use, you know, this is like an informal way, 4 palm 2. Now, for those of you that do gambling, for those of you that gamble, right, you, or play poker or something, you probably have used palm and com, permutation. Short form, you can call it, this is an informal one, palm. 4 palm 2 or palm 2 from 4, right? 4 palm 2 or palm 2 from 4. Okay, this is an informal way, okay? So, we now see it gave us 12. It gave us 12. Now, because we want to develop a formula for this, I want to show you, I want to develop a formula for this. Now, you ask yourself, how did you get 12? We've listed it, right? But what if we have 20 palm 7? You can't come and start listing it. It's too much. So we need a formula for it, okay? To find how many ways it's going to give us. So we now see that, okay, we want to take any 2 from that 4, right? So the first can be arranged in any 4 ways. You can put it in any 4 ways, right? And the second can be arranged in any 2 ways. That's another way you can take it. Let's say this is like saying palm 2 letters from 4 letters, right? In all, how many ways can 2 letters be arranged from 5 letters? So you can say it this way, that the first can be arranged in 4 ways, and the second can be arranged in 3 ways. So it gives you 12. We will still need this, okay? So let's keep it. Now let's do number 5. List the 3 permutations of A, B, C, D. A, B, C, D. Now, these 3 permutations of A, B, C, D. Okay, so let's list it. Let's go ahead and list it here. Probably take us some time, but that's fine. Okay, now for number 5, list the 3 permutations of A, B, C, D, right? A, B, C, D. So just like we did for 2 permutations, so let's go ahead and list this for 3 permutations. So it's going to be, we can have A, B, C, A, C, B, A, B, D, A, D, B, then A, C, D, A, C, D, A, D, C, right? Then we can have a B, A, C, B, C, A. B, A, D, B, D, A. B, C, D, B, D, C. Right? Then we can have a C, A, B, C, B, A. C, A, D, C, D, A. C, B, D, C, D, B. Okay? Then we can have a D, A, B, D, B, A. D, A, C, D, C, A. And D, B, C, D, C, B. So how many we got? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So we have 64. I'm sorry, 6 times 4, 24. 24 ways. Okay. So that means when we palm 3 from 4, we get 24. Okay, or number of number of ways to arrange 4 items or 4 elements, taking 3 elements at a time. Alright, so 4 palm 3 will give us 24. Of course, we now have that the first can be arranged in 4 ways, second can be arranged in 3 ways, third can be arranged in 2 ways. So that gives you 4 times 3 times 2, which is 24. Okay, so let's now find a formula for n palm r. Let's now find a formula for n palm r, since we've gotten this, okay? So, can I erase? Alright, so we now have that 4 palm 2, we got it as 4 times 3, of course, which is 12. So, and 4 palm 3, we got it as 4 times 3 times 2, which is 24. Now, we have that when we have 4 palm 2, right, we have 2 spaces. Okay, we have 2 spaces for that. First one in 4 ways, second one in 3 ways. Alright, now, you see that this 3 is 1 more than 2, right? So this is kind of 3 to be 1 more than 2. 1 more than 2, right? That's 1 more than, you can say 1 more than 4 minus 2, yeah. 1 more than 4 minus 2. 4 minus 2 is 2. So 1 more than 4 minus 2. Then this 2 here, where we stop, is 1 more than 4 minus 3. So let's see, if we have a 9 palm 4, 9 palm 4, where do you think we will have, here 2 spaces, 3 spaces. So 4 will be 4 spaces. We have 9 times 8 times 7 times 6. It's going to be 4 spaces. And we notice that this last one, 6, is 1 more than 9 minus 4. 1 more than 9 minus 4. Okay? So, we see that if we have n palm r, right, it's going to be arrow spaces. Of course, we don't know what is. We don't know how many arrow spaces. But we will have, of course, n times n minus 1. Of course, 9 minus 1 is 8, yeah. Times n minus 2, right? Up to what? Up to 1 more than n minus r plus 1. Up to n minus r plus 1. So this is what we're going to have if we have n palm r. Right? Yeah, because 9 minus 4 is 5. So 5 plus 1 is 6. So when you subtract and you do that, because this is like saying 9 minus 4 plus 1. And this is like saying 4 minus 3 plus 1. And this is like saying 4 minus 2 plus 1. Remember? And your order of operations, for the subtraction and addition, or addition and subtraction, it moves from left to right. So this will be n minus r plus 1. Okay, we don't stop here. Let's continue. Let's find this formula, okay? So it will be easier for us to finish up the rest. Okay, I have to erase, but I will still need this. So, what does this give us now? Permutations of n objects taking arrow objects at a time, or permutations of n items taking arrow items at a time. So, n palm arrow, we got n times n minus 1 times n minus 2 up to n minus r plus 1. Okay? So, multiply the right hand side by n minus r factorial, and this is just the proof, you know. Please don't ask me why, because if I start explaining it now, it will be too long, okay? Let me just prove this and get the formula, and then we continue. All right, so n minus r factorial, of course, let's multiply, of course, this is like saying multiply by 1. It's like saying like that. So n palm r will give n minus 1, n minus 2, up to n minus r plus 1 times n minus r factorial all over n minus r factorial. Of course, this is like saying everything, you know. So this is n palm r will be n times n minus 1, n minus 2, up to n minus r plus 1 times n minus r factorial all over n minus r factorial, right? Okay. Now, n minus r factorial, let's kind of work on it. Now we see that the n minus r factorial, of course, you already know that n factorial is n times n minus 1 times n minus 2 up to 2 times 1. Okay, keeps going, the ellipsis up to 2 times 1. So if we have n minus r factorial, it's still going to give us n minus r times n minus r minus 1. Right, in this case our n is like n minus 1. Our n is like n minus r here. Then times n minus r minus 2 up to 2 times 1. Okay? So if we kind of put it right here, and you know what? I'm just going to erase this up to 5 so that I will have space here. So we will now have that n palm r is equal to n times n minus 1, n minus 2, up to n minus r plus 1, then times n minus r minus 1. You can do that up to 2 times 1, right? All over n minus r factorial. Now, if you look at this, you see everything still, if we notice that this first one is still n factorial. I mean, it's still n factorial because you keep multiplying and multiplying and multiplying until you eventually get to 1. So, this is like saying that n palm r will now be n factorial all over n minus r factorial. This is actually what we need. So when we say palm 2 from 4 or 4 palm 2, you just plug it in here. And we will solve some problems and we'll see how we can use it. Okay? Alright, let's finish up the video. Let's finish up the problems. I think the video is getting long. Alright, now, number 6, determine the number of permutations of the letters of the word mad. Of course, mad is like saying A, B, C, D. You know, you can have M-A-T-H, M-A-H-T, M-A, you know, M-A-H-T, M-H-A-T, and keep on going, right? Okay, but it's just 4 factorial because it's 4 items, 4 factorials, and that gives us 4 times 3 times 2 times 1, 24 permutations. Okay, now number 7, in how many ways can the letters in the word Samdom, be arranged if the 2 M's are distinguishable and then if the 2 M's are indistinguishable? Okay, now let's look at the word Samdom, and that brings us to distinguishable and indistinguishable elements. How are we going to palm this? And you know, this has been a confusion. If you have elements or items that are distinguishable, how are you going to permit? If you have elements that are indistinguishable from each other, how are you going to permit? Okay, if they are distinguishable, that means they can, that means they're different, right? They're distinguishable from each other. So we kind of have M1, M1, and DO M2, whereby M1 is not equal to M2. This is distinguishable. I'm answering A. Distinguishable. So how will you permit? How will you arrange it? Of course, you will just count 1, 2, 3, 4, 5, 6. It's 6 factorial. And 6 factorial, I think, if you do it 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30 times 4, 120 times 3, 360 times 2, 720. I didn't even need to use my calculator. Okay, 720 ways. Now, but what if they are indistinguishable or duplicate? We call it indistinguishable or duplicate. Or duplicate. Duplicate. Duplicate elements. Right? The way we arrange this, you know, because it's kind of, it will be, if there are duplicates, you count M and M as kind of one. Like when you arrange it, I'm not going to list it now. It's going to take time to list it, to be honest with you. So I'll just have to write the formula the way we do it. Okay, but if they are duplicates, we don't kind of count them as we will count if they were distinguishable. Okay, so if they are duplicates, we'll first of all count them as if they, we'll first of all find a number of ways of arranging them as if they were distinguishable, and then we divide it by the number of ways of arranging the duplicates only. So this is now 6 factorial. The number of ways you can arrange this will now be 6 factorial. As if, first of all, do it as if they were distinguishable. All over. How many duplicates do we have here? The 2 m's. 2 factorial. And that's how you do it. You know. So this will now be 6 times 5 times 4 times 3 times 2 factorial. All over 2 factorial. You might ask me, why did I stop at 2 factorial over 2 factorial? And by the other videos I will do, you will see why. There are some permutation and combination. You don't need to write out everything. You just stop at where you can stop and cross out. Because 2 factorial is still 2 times 1. Right? Where you can stop and cross out. So this is 6 times 5 is 30 times 4, 120 times 3 is what? 360. Where is? So there are so much to learn on this topic. So watch out for other videos. Thank you so much, students, for listening, and you have a great day.